All right. Okay. So happy Monday, guys. And it is already week 4. And we'll just jump right into it. Um, so today we're going to cover data wrangling with dplyr. I realize, again, some of you may have already seen some of this stuff in Stats 20, but some of you have not. And so I think this is a good topic that we should cover. Oh, okay. I put this slide in. This is the grumpy professor chat. Okay, so I do have to kind of air a few grievances are here. Okay, and I just want to say, once again, before you submit your homework, please make sure you read through your entire homework output to make sure that it looks the way you want, and make sure all the requested output is visible. I've received, a few regrade requests for submissions that, look like this, and unfortunately, this is not going to get points in a regrade. This is the file name, wasn't read in, and so the month convert portion on the homework didn't run, which is unfortunate, and the student's going to lose points. Okay, and and it's not fun. It's not fun losing any kind of points because of a silly mistake, and a silly mistake like that, might cost you a percentage point or two, in your final course grade. In my opinion, this is a relatively small price to pay. But if it motivates a student to kind of pay more attention to these details, I think it's worth that consequence. When you go applying for jobs, one of the things it said that you'll often see is that they're looking for someone detail oriented. And what that means is that a silly mistake in a job like that can have large consequences. And they want somebody who's going to double check and triple check their own work, not relying on someone else to check their work for them, before kind of making any kind of submission. And so, you could just imagine, the consequences of, some of you are applying to, or going to think about applying to graduate school, and you could imagine the consequences of using the wrong version of your personal statement, because you might be applying to different programs and you might say, like, I'm a perfect fit for this school, but then you send the wrong version to the wrong school, and that's going to look really bad on your application, right? And that's just a silly mistake, but it's those kinds of things make a difference. And you really, like, it's also very obvious if you have, like, if your statement's like Miles Chen personal statement, Columbia, Miles Chen personal statement, Stanford or something, and it's going to be obvious that you're making all of these things. So just, you want to have the appropriately titled thing, right? Other embarrassing things that could happen: CCing the wrong person on an email with confidential information. That, these are small mistakes, but serious consequences. And you can, like, if it's a legal matter, it could be very problematic, right? And then other things like entering the wrong digit on a bank account number, or an extra zero in the dosage of a medication or something. These things can have major consequences, even if they're all just kind of small detail mistakes. And so, I want you guys all to achieve your own dreams and your full potential. And I don't want silly mistakes like these to be holding you back. Okay, so anyway, that was my grumpy professor chat there. Let's talk about dplyr, okay? And after I said that, my slides are probably going to be full of typos and small mistakes too. But we're all susceptible, and we're all responsible for checking our own works here. But okay, so dplyr is a core part of the tidyverse, and you just load it up with library dplyr, or if you want to load up the full tidyverse, library tidyverse. And and a bunch of my slides are taken directly from the dplyr vignette, which is going to be an excellent resource to kind of walk you through it. But as far as, when you're working with data, a lot of times you have to think of what it is that you're going to do, and you've got to kind of describe those tasks in some form that a computer can accomplish, and then you write it out and execute the program. And dplyr makes this easier because it gives you a certain set of verbs And you have to kind of think of all of your actions in these simple verbs, okay? And so we'll take a look at these verbs here. So this is how dplyr describes itself. It says dplyr is a grammar of data manipulation, providing a consistent set of verbs that help you solve the most common data manipulation challenges. So you have select, which is going to pick variables based on their names, filter, which is going to pick rows or cases based on their names, mutate, which adds new variables, arrange, which kind of changes the order, and summarize, which will take multiple values and reduce them down to a single summary value. And they also combine nicely with another verb called group by, which kind of allows you to perform any of these operations by group. There's a cheat sheet that's available, and it's very handy to have, and I recommend taking a peek here. Okay. Let me go ahead and give you your first view quiz answer for today. First view quiz answer is E as an elephant. E as an elephant. All right, so let's take a look at a few examples here. There's a data set called starwars in dplyr, and it contains information about Star Wars characters from the first 7 Star Wars movies. So since this data set, there was also The Last Jedi and Rise of Skywalker and stuff. But anyway, we've got these different characters, and so we'll and this is kind of what it looks like. All right, and so you can see this is a tibble, and so it prints only what fits on the screen, and by default only the first 10 rows here. Okay, so we have Luke Skywalker, and it contains information like height, mass, hair color, skin color, eye color, and I'm not sure where all of this information comes from, but this is what we have. Okay, so you can select columns by using select. All right, and so as far as select goes, you provided the name of the table that we're working with, and then or the tibble that we're working with, and then the names of the columns that we want to select. Okay, and so we have the name. So R2D2 is from Naboo. He is a droid. It is a droid, I guess, and it appears in 7 films. Okay, all 7. All right, when we can use the pipe, and so what the pipe does is it takes the results of what's in front of the pipe and inserts it as the first argument in the function that comes after the pipe. All right, so when you have x piped into function y, that's effectively f of x comma y. All right, and so all of the verbs take the form of the action and then the name of the table or tibble or data frame that you're working with. Okay, so in this case, we're working with Star Wars, and then we're going to select the columns name, homeward, species, film. And you can turn this into this form. Star Wars gets piped into select name, homeward, species, film, and they are exactly equivalent, right? And so you get the exact same result. And then what you can do is then you can take this and pipe into another operation. Okay, we have a question that says, can you pipe a vector of parameters? So there are ways to kind of pipe things into arguments that are not the first location, and I don't know them off the top of my head, but you use the dot to kind of pipe things into locations that are not the first argument. So the shortcut to insert the pipe is Control or Command Shift M. Okay, and it seems like we were on the same page as far as what's the shortcut for doing that. And we would and so we can do more stuff with this. And so just let me show you a few more examples of select, right? So if you don't want to select columns, right? If you want to drop certain columns, you can use a minus sign, okay, negative sign, and it's going to drop these columns, and it's going to select all of the other ones. And so here I'm going to pipe Star Wars into the select function. And then from there, I'm going to just ask for the first 3 entries that come back, right? And so we get, this is what we get, okay? You can also use the colon operator, right? And so the first, we can say, I want to select from name through eye color, and I can just do name colon eye color, and it's going to select those using the colon operator, okay? So it selects those. And again, I'm asking just for the first three rows here. The dplyr comes with special functions that can be used for selection. And so you can use these kind of operators such as contains, starts with, ends with, matches, everything, numeric range, or one of, okay, with some kind of name vector here. And you can learn more as we read these select helpers here. And so as far as we do the select, we can say, I want to select the columns that ends with color. Okay, so we've got hair color, skin color, and eye color here. Right. Does select only work with tables, or will it work with data frames and lists too? So it will work with data frames. And what dplyr will do is it'll take the data frame and kind of automatically turn it into a tibble. And it's always, the results of dplyr functions will always be tibbles. So you can provide data frames in the as the argument for the argument here. Okay. So here we're selecting all the columns that end with color. You can also provide a regular expression. Okay. And so here, this regular expression means that the name of the column ends with an S. Okay. S $ means ends with an S. And so we're going to say select the name column along with columns that match this regular expression, which will be all the columns that end with S, which will be mass, species, films, vehicles, and starships. Okay. Yeah, we could have also just done ends with apostrophe quotation S, and that would have been absolutely equivalent. But you can, I guess, I haven't taught you guys regular expressions yet, and so I'm just keeping these to be very simple regular expressions without having to make an aside here. Okay. You can also select with a vector of names. So if you create an object in your workspace or environment called vars, which has the names of the variables that you want to select. So for example, you might create this in some other part of your code. You can then say starwars select, and then you have to put the vector into a function called all-of, and this tells dplyr that these are literal names that want to be matched. Okay, versus when you normally use the select things, you don't actually have to put quotes around things like name or eye color, right? And dplyr is not going to get confused. It's not going to say eye color object not found. It's going to understand that this is the name of a column that you want to select. Okay, that's kind of built into the functionality here. Okay, yeah, homework 3, I have not posted that. I will post that later this evening. That's my hope, to get it posted later this evening, and I'll don't worry, I'll give you plenty of time to complete it as well. I didn't want to post it too early because there's a lot of stuff that relies on dplyr and other things, and if I posted it too early, I know some of the students would have worked on it right away, and then they would have questions like, how do we do this? And it's just like, I haven't gotten there yet. So so I'm going to post it after tonight, and then you can start working on it. And there will still be stuff that I haven't covered, like the regular expressions, but that will come later this week. Okay, so that's selecting your columns. Now we want to talk about selecting rows, okay? But except we're going to call this filtering. We filter the rows. So we select columns and we filter rows. So filter rows will specify which rows it should return, okay? And filter can use any kind of expression that's going to turn into a logical vector that has that's equal, I'm sorry, a logical vector that's going to have a length equal to the number of rows. Okay, so for example, I mean, some of these things are going to make sense where I just say name equal R2D2, and then so that's going to be a bunch of true false values, and it's only going to be true where name is equal to R2D2, and it's going to return only that particular row. All right. Here is another example. I can say I want the species value to be either human or droid. Okay, so this is going to return all the humans and droids that appear in the movies. All right, and we also want height to be under 175 centimeters. All right, so we're going to get Luke and C-3PO and R2-D2 and Leia and whoever all these other people are. Okay, so if you use a comma, that's equivalent to using the and sign, and it's going to say, you know, all of these things must be true, right? And both of these things are logical vectors. They're going to return logical vectors of however long our table is. Okay. Filter can also be used with regular expressions. So especially if you're dealing with string data, you can create string detect or something like that, right? So there's different kinds of logical operators. So string detect is going to return a logical vector. And so here we want to find all of the names, all the characters where names begin with a capital F, okay? And we have Finn from the new movies, and I don't know who this is. Okay. Question says, would we have to create a different vector for OR statements? So for OR statements, actually, that's the next slide. You put in a vertical bar here, okay? And so for filter, you can say hair color equals none, meaning we want people who don't have hair, or eye color is black. Okay, so we have Darth Vader, who doesn't have hair. We have Greedo, who has black eyes. Okay, and this is what we have. And I guess we have a total of 38 people appearing here. Okay, and again, I've piped these into each other, and so I said, take Star Wars, just filter these rows, and then from there, pipe the results into this select statement, where we're going to just select name, species, home world, hair color, and eye color. Okay, versus all of these other ones, it's been trying to return all of the columns. And here we're only returning the columns that we've selected. All right. So far, so good. Okay. Once you've selected or filtered, you can also pipe that into an arrange statement, and arrange is going to sort the resulting what do I call it? Sort the resulting data. Okay. So here we go. We can say, all right, yeah, I want you to select the name, the birth year, the height, and the mass, and then arrange it by birth year. Okay. And this is birth year is measured in the Star Wars universe. It's years before the Battle of Yavin, I think. And that's kind of their 0 point. And so Yoda was born 896 years before the Battle of Yavin, whereas Jabba the Hutt, I guess this is his full name, and Chewbacca was, you know, these are their ages. And so so this is what we have, okay? And so here we're saying order by birth year and then by mass, okay? So I have no idea who this is, but was born in the same year as Qui-Gon Jinn, but then we arrange them based on their mass afterwards. Okay. Question, what does the string detect function do? So the string detect function is something that we're going to learn about when we talk about regular expressions. but it's going to see, does it detect this regular expression pattern in the string? And if it does, it's going to return true. And if it doesn't, it returns false. So string detect returns true or false if it detects, if it finds this regular expression pattern. This regular expression pattern means the string has to begin with an F, okay? And so it's going to return trues when the string begins with an F and false when it doesn't. And we get the characters where their names start with F. How does arrange deal with NAs? Oh, I don't know. I got to look at that up in the help or try an example. It looks like, well, it doesn't throw them out. It looks like it puts them, at the end. So here's an 82 and the 75 is followed by the NA. So both of these people were born in year 82 and then they end up in NA. Palpatine is the same age as Klieg Lars. Huh, interesting. Okay. You can also select rows based on their position with slice. And so slice just says, I want the fifth through 10th row or something like that. And so this will do that, okay? And it renumbers them through to be rows 1 through 6, but you're selecting from the original data frame, you're selecting the 5th through 10th rows. Descending by birth, but mass is increasing 92. To example, what is this? Hold on, Simon says descending by birth year. Yeah, so we're arranged by descending by birth year and arranging by mass in increasing order. Yeah, so we have 92 here and here, okay? And then if it appears that if a value is NA, it arranges it after the values that do exist. Okay. There's also a function slice sample, and this will just select kind of however many rows you want. And so this, a lot of times after you run something, you might just say like, give me the head, top 5 or something like that. But you can ask for slice sample, and this is going to kind of give you a peek at maybe the broader data set, just in case, if values are already arranged in a certain way, you kind of want to make sure your operation is behaving correctly throughout the data set. And so you can just ask for a random sample of say 5 rows. Okay, and so we get 5 of these rows here. Okay, there's also slice min and slice max. And this will select either the lowest or the highest values for a particular variable. So here we can say slice max. We want the ones with the greatest mass, the 3 with the greatest mass. And so we have these 3 characters, okay? And this is similar to using arrange and then a head. I guess arrange descending or arrange, for slice min, it would be arrange normal and then a head. But you can also just perform a slice max or a slice min. Okay, as we continue on, we can also create new variables with mutate. Okay, and so here I'm going to say I want to create a new variable called height underscore in for height in inches, or I'm going to take the height, which is currently measured in centimeters, and I'm going to divide by 2.54 to get the person's height measured in inches. Okay, and I just want the kind of the first entry, which is on Luke Skywalker. All right. But when you use mutate, the result, okay, the original data set has 14 columns, and mutate just kind of tacks on the new column at the very end, right? So it takes all kind of the original 14 variables, which also includes vehicles and starships, and then it includes the new variable that you just created. Now, depending on the size of your data set, maybe you're only interested in just a few of these things. So you'll often pair your mutate operation with a select operation. So here I'm saying create this new column called height in inches, And then I want you to select the name, the height, and the height in inches. And so we get Luke Skywalker, 172 centimeters, 67.7, so about 5'8" inches. Okay, just the first op value there. When you use the mutate operation, the result of mutate has to have the same length as the number of rows in the data set, okay? Because what it's going to do is it's going to add an entire column. So if my original data set has 87 values, then the result of mutate needs to create 87 values. So you cannot use functions like mean, because what mean does is it takes a bunch of values and it returns 1, right? If you take standard deviation, these are some mean and standard deviation variance are what we call summary functions, and that it takes several values, like you have 10 numbers and you say, what's the mean of these 10 numbers? And it's going to return 1. So mean is not going to work for mutate. But you can use something called the cumulative mean, okay? And the cumulative mean takes the entries so far and returns a mean. And so the cumulative mean is sensitive to the order in which the values appear. And so we start off with Luke Skywalker with a mass of 77 kilos, and the cumulative mean so far is 77. C3PO appears with 75, and so the cumulative mean of these two values is 76. R2D2 has a mass of 32, and so the cumulative mean of these three values, 77, 75, and 32, is 61.3. And Darth Vader, once you include Darth Vader, the cumulative mean is 80, and so on and so forth. So in order to use mutate, you need to have a result that is of the same length as the number of rows. Okay, so things like vectorized operations such as height divided by a number, or if you wanted to take kind of you could do something like a BMI calculation where you do a ratio between the height and the mass, and I forget the exact numbers that get used in a BMI calculation, but you could do that because it would be different for each individual, and that would appear here. Okay, let me go ahead and give you your next quiz answer. Next quiz answer for today is C. C as in cat. C as in cat, like C3PO. Okay. So here are some useful functions for mutate. We have pmin and pmax. These are the element-wise min and max. Cumulative min, cumulative max, cumulative sum, cumulative product, between, which will be give you logical values, the cumulative mean. We also have lead and lag, which will copy values with some kind of offset, and then entile, which will bin the values into n different buckets. So let me just give you a few examples here. So I have the cumulative minimum. Okay, so this is going to be kind of the running minimum value seen so far. We have the ratio, which is going to be the mass divided by kind of the mean of the mass of all values. Okay, so we're going to take the mean of everybody. Okay, this is pmin, pmin of mass and birth year. And so this is going to perform the element-wise minimum. Okay, so let me just show you, and then lag is going to be an offset by 2. So here is Luke Skywalker, mass of 77. And so far, the cumulative minimum value is 77. C3PO has a value of 75, which is lower than 77. So the cumulative min is 77. R2D2 has a mass of 32. And so the cumulative min is 32. And everything else that appears has a heavier mass equal to or greater than R2's mass. And so the cumulative min just remains 32. So this is just kind of the minimum value seen so far. The ratio is take the mass and divide by the mean value of everybody. So it looks to be that if you take the mean of everyone, it's something around 100, maybe 98 kilos or something. And so Luke is 80% of that, 79% of that, whereas Darth Vader is 1.4, times the total mean mass. The p-min is, we're looking at just these two columns, mass versus birth year, and it just says take the minimum value between these values in the column, all right? So as far as here, 19 is smaller, right? This doesn't have a semantic meaning here, okay? But versus C3PO versus, 75 versus 112, 75 is smaller. 32 versus 33, 32 is smaller. 136 versus 41.9, 41.9 is smaller, okay? All right, and then lag is just this column here. We said take the lag of mass year min and offset it by 2. And it's basically a copy of this entire column, but offset by 2. All right, and so this could be useful if you wanted to do some kind of comparison of if you have a time series value and you need to perform some kind of lag calculation, how does this year compare to 5 years prior or something like that. Lag is useful for that. Lead is just the opposite. It offsets it in the kind of the opposite direction. I think the true power of dplyr comes with the summarize functions, okay? Summarize is spelled with an S. They also have summarize with a Z, which is how we spell it in the US. Hadley's from New Zealand, so they spell it with an S, and I'm accustomed to seeing summarize appear with the S as far as this goes. So summary functions, what they do is they take multiple values and then they summarize them into a single value, right? So here I'm going to take Star Wars. I'm going to just select the height and the mass, and then I'm going to create a summary table, okay? And we're going to say, all right, what's the average height? What's the average variance of the height? What's the average mass? The minimum of the height, the maximum mass, and the count. And here I'm going to do, mean, var, mean, min, max, and so on and so forth. I'm asking na.remove equals true. And these are basically just the regular old functions that you use in R, right? When you ask what's the mean of a column or something like that, and it provides all of these things, okay, in this kind of table. Now this feels like a lot of work just to get these values, and you probably would have just said mean of Star Wars $height to get the the same values that you see here. But summarize is paired up. When paired up with the group by function, becomes very powerful. All right. Okay. One thing to note is that the result of summarize is always going to be a tibble. Okay. So the result of any dplyr function is always going to be tibble, which means you can then pipe this summarize table into another dplyr function. But let me just go into an aside and talk about the group by function. Okay, so the group by function will go through the data set and it will assign groups. Okay, so here we have the data set has 87 rows, and I said group by the species. Oh yeah, the N question is how many values, how many rows appear, right? So how many, the count of the rows. So here it just says 87. Okay. So we have 87 in the original data frame or original tibble. Okay, and then we say group by species. And when we do that, it doesn't look like anything has happened, but it does say this. It says I've detected 38 groups, 38 species groups. Okay, and this becomes very powerful when you apply it, use a summary function after that. Okay, so here we're going to say Star Wars group by species, and then from there select the name, the height, the mass, and the species, and then summarize. I want the mean height, the standard deviation of the height, the mean mass, standard deviation of the mass, and the count. Okay, and so we have, yeah, I'm not, like, I like Star Wars, but I have no idea what these things are. Okay, so we have the Alina species. Okay, and we have one individual in the of the Alina species, and has a height of 79 and a mass of 15. The basilisk, the Syrian, the Chagrian, the Claudite. Anybody know who these characters are? There's only one of each of these things, okay? And so, so there's no standard deviation, right? If you only have one value, there's no standard deviation there. And so we have, so these are the values here. Okay, we have 6 individuals of the droid species, okay? And the mean height for droids is 131. The standard deviation of height is this. Okay, so again, this is my summary table. And because there are 38 groups, right, over here we had 87 in the original table. There's 38 groups, 38 different species. The resulting summary table is going to have 38 rows. Does that kind of make sense? What I'm going to do is I'm going to say, you know what, let's group by species. Let's summarize it. But you know what, I only want to select, I want to filter down to where the count is greater than 1. Okay, why does this look like SQL? Because it's a lot like SQL. Okay, dplyr is a lot like SQL. It's intended to handle kind of working with a table, very much like SQL, and to kind of filter out and give you the information that you're looking for. Okay, so here we're going to say, you know what, summarize it, which is going to kind of give me this table of 38 by 6, 38 rows and 6 columns. And then we're going to say, I only want ones where the column is greater than 1, and I want them to be arranged by descending order. So here we get humans. We have 35 human characters. The mean height is 171. Standard deviation is 12.5. We have 6 droid characters with a mean height of 131 and standard deviation of 49.1, etc. We have 4 characters where the species is unknown, etc., etc., etc. Okay. What does group by do on slide 32 before you summarize anything? It basically just puts in metadata into the table. It doesn't do anything. Okay, all you're just saying, take the table and then I want you to identify groups, and then it just identifies the groups, but it doesn't actually create a column called groups, because the groups already, that column already exists. It's the species column. Okay, it's basically just applying some hidden metadata that's not visible in the printout, but it does say the groups do appear here. Okay. Why is there a dot at the end of mean height? Where do I have a dot at the end of mean height? Oh, this is to indicate that this is a type double, okay, and not, well, actually, no, actually, I'm not sure. It probably means that there's decimal places here, but I'm not entirely sure, because we're getting 82.8, 69.8, 48. I don't know why there's no dot here, but there's a dot here. It probably means there's decimals, but just decided not to print them out. Okay, and whenever you summarize it, it's often going to give you this warning, but this is a warning that you often don't have to worry about. Okay. So you can do further things, such as group by, and then I can add a mutate here, right? So here I'm going to say, so notice, so one thing about dplyr is that this code, it actually becomes reasonably, once you get used to the verbs, it becomes reasonably easy to read what is happening. And that's one of the beauty of using pipes and nicely written dplyr code. So we're saying, take the Star Wars data set, filter to the rows where the species is either humans or droids, okay? Or the species is missing, okay? And then from there, select the columns name, species, and height. I want you to group by the species, and then add a column for z-score of height, okay? We're going to do z-score of height, where we're going to do height, take the height minus the mean of the height divided by the standard deviation of the height, okay? And notice I don't have a summarize, I have a group by, right? So I'm not summarizing by the species, but I'm performing this mutate operation based on the groups, okay? So we're gonna get Luke Skywalker has a height of 172, and compared to his group of humans, he has a negative z-score. Okay, C3PO, okay, C3PO is a droid with a height of 167. Compared to other droids, C3PO has a positive z-score. Okay, so normally 172 is a larger value than 167, and so we would expect the z-score to be greater for 172 than 167, but it's not, because these z-scores are calculated based on groups by species. Does that kind of make sense? So the average height for humans is 177. The average height for droids is 133. And so as far as Luke Skywalker, he's below average for humans, and C3PO is above average for droids. Okay, so why do we need group by? The question is, why do we need group by if, what if we had no group by and then we use mutate? Well, that's actually the next slide, right? So without the group by, this is the next slide. And so I've commented out the group by operation. And so now what this will do is it's going to calculate z-score based on the mean of everyone. Okay, the mean of everyone is back here. The mean of everyone, the mean height is 174. And so Luke Skywalker is slightly, wait, oh, I'm sorry. Not everyone, it's the mean of all humans and droids or missing species. So the mean height for everyone is something a little different. Luke Skywalker is now slightly above average, and C3PO is slightly below average here, okay? So this one is their z-score versus the rest of their species based on their groups. And this is the z-score based on everybody, okay, when you take out the group by. So by doing group by before the mean, it calculates the mean height by groups versus the mean height of all values. That is correct. Does that make sense? I hope the difference between this slide and this slide makes sense. And so C3PO is above average when compared to other droids, but below average when compared to, actually not all characters, all human or droid characters in the data set. Human or droid or missing species characters. Okay. I hope that makes sense. The here's just another table, and this is, you can actually perform multiple levels of group bys. Okay, so this is just a silly table where we have Afghanistan, Brazil, China. The year is 99, 2000, 99, 2000. We have males and females, and the number of cases of some mystery diseases, 1s, 2s, and 3s. Okay, so just a toy data set, 12 by 4. But let me just show you kind of multiple levels of group by. Okay, so I can say group by country and year. Okay, country and year is going to create 6 groups. We've got Afghanistan 99, Afghanistan 2000, Brazil 99, Brazil 2000, China 99, China 2000. And we're saying, and when you summarize, give me the sum. Okay, so it takes the 2 rows for Afghanistan 99 and it summed them and it gives me back 2. It takes the 2 rows for Afghanistan 2000, it summarizes them by adding them up and giving me 2, so on and so forth. So we say group by country and year. Okay, so this is summary table. So we have group by country and year. There's actually, because we said group by country and year, there's still an inherent grouping here, and they're grouped by country still. And so we could summarize even further, and it says take these values and apply a summary of sum here, and it takes these 2 rows where the country is Afghanistan, it adds them together and gives us 4. It takes the 2 rows for Brazil and gives us 8, and takes the 2 rows for China and gives us 12. And then I could further summarize here, and it's going to add all of these values up, and it's going to return 24. Okay, so I have multiple groups here based on country and year. If I decided, there's a typo here. If I decided to take that and say group by year, then country, okay, then it arranges it accordingly. So we have 1999, Afghanistan, Brazil, China, the year 2000, Afghanistan, Brazil, China. Okay, and I have two groups, a group for year 99 and a group for the year 2000. And I can again apply summarize here, and then I would get a summary for 99. There were a total of 12 cases, and a summary for the year 2000, a total of 12 cases. Is that all right? As far as applying kind of multiple levels of groupings and summaries. Okay, I'm probably going to run out of time here. And this is, you know, if you've seen SQL before, SQL before, the two table verbs will look also very familiar. So dplyr also comes with some two table verbs that allow you to kind of combine tables. And what we're going to look at is we're going to look at mutating joins, okay, which means it's going to add variables from one table, add new variables to a table based on matching rows in another table. Okay, there's other types of joins, filtering joins and set operations, which you can read about when you read the dplyr help online. But the mutating joins are probably the most frequently used ones, and they also resemble SQL or SQL the most closely. Group by question. Group by is like filter with a factor. Group by is applied by rows, okay, but it's not a filter. It specifies groups, and group bys are kind of get paired up with summary operations, and it will perform the summary or the mutate operations according to groups, right? So anytime you have a summary thing where like calculate the mean, it's going to be applied by the group. Okay, so here I've created two tables, okay? People, there are 4 people, Adam, Betty, Carl, and Doug, and they have states. They're from California, New York, and Texas, okay? I also have another table of kind of state information. The abbreviations are California, New York, are CANYWA, and the state names are California, New York, and Washington. Okay, so the left join will take all the values from the left table, in this case, people, and it's going to find the matching ones, and we're going to match it by matching the state name, okay, the state column to the abbreviation column. Okay, we're going to say state equals abbreviation here. And so it takes all the ones on the left. So we have all 4 rows from people. There's no match found for Texas, so it gives me an NA here. But the other ones, it finds kind of the full state name here. The right joined is kind of the opposite. It keeps all the ones in the right table and returns kind of matching ones from the left. Okay, and so here we have CANY and WA, and then it finds rows and values on the left that that are equal here. Okay, why is it in single equals here? Okay, because what we're doing is actually providing it a named vector, and it's not doing a logical comparison here. It's doing a matching based on these column names. So it's matching based on column names. It's not doing the logical comparison. So that's the right join. The inner join only gives the intersection where both names have to exist in both columns. So that's going to be just California and New York here. And then the full join is kind of the union. And so it's going to give you back everything that kind of matches, and it'll just fill in, populate with NAs for things that don't. Okay. There's a few ways to specify this. By default, if you just have 2 tables with names that have shared names, it can work very, very quickly and easily. But yeah, if you're familiar with SQL, dplyr is going to look and feel a lot similar, and it brings kind of a lot of the similar vocabulary, even though the names are a little bit different to the operations to R. Okay, let me go ahead and give you the last quiz answer for today, and we'll call it a day here. Okay, last quiz answer is A. A as in apple. A as in apple is your last quiz answer. Okay, that covers dplyr for today, and we will I'll post up your homework, and we'll see you guys on Wednesday.